I really do appreciate the opportunity to come visit with you. Thank you, Cameron, for your support over the years. I try to get my reports in on time. Sometimes you have to remind me, and I appreciate your patience there too. I thought today I would just kind of cover a smattering of AgriLife projects and accomplishments over the years, contributions, really promoting co-workers, because I'm blessed to be able to work with a lot of really smart people. Some of them are listed here. Thomas Marek, a research engineer up at Eder and Bushland, has done some really phenomenal work. I'll talk a little bit about that. Prasanna Goda at UCA ARS. Jim Berdowski, a lot of you know him at Halfway. Freddie Lamb, Danny Rogers at Kansas State University. They're really great to work with. Recently, and Paul Kalezi and Terry Howe at USDA ARS Bushland. Terry has retired relatively recently. He settled in the Austin area near the grandchildren, but we still have his email address, and we still get to peg him and use him a lot for manuscripts and standardization and other issues, so we really appreciate that. Funding and in-kind support, all this work takes money, and we do appreciate a lot of the support comes from the USDA ARS Ogallala Aquifer Program. That helps facilitate a lot of those multi-state collaborations and the work with USDA ARS, which is a really good opportunity, again, for me to work with really smart people, so that's great. Texas Water Development Board and agricultural conservation projects that Cameron has been very much involved in. Commodity groups, including Cotton Incorporated and Texas Corn Producers Board, we really do appreciate the support and your guidance on what the questions are that we need to address. And of course, the Texas A&M AgriLife, the folks who pay my salary, for which I'm really appreciative. If you've seen a lot of my talks, you've probably seen this slide before, but I really try to drive the point home that why we have such a high rate of adoption of efficient irrigation technologies in the High Plains. We get calls. I had a call yesterday from a retired extension specialist from Utah State, and he'd been talking to other extension specialists and researchers from around the country, and he ended up calling us, what are you doing down there? You have this really high rate of adoption of subsurface drip irrigation, you have a really high rate of adoption of low pressure center pivots. How, why? How does it work? And I'll get into that a little bit. But first of all, water is a limiting factor in this area. It has been for a while. So by necessity, our growers have been progressive adopters of these advanced irrigation technologies, or efficient technologies. These technologies are good fits for our systems, for our water systems, for our capacities, for our groundwater-based irrigation systems, and for our production systems. Part of the reasoning behind that is because we have excellent applied research programs. I'm a relative newcomer. I've only been here 16 years, but I'm a relative newcomer in the business. A lot of developments, I'll talk about that, but low pressure center pivots, subsurface strip, well suited to our production systems, our cotton, our grain, really well adapted. A critical mass of well qualified and experienced irrigation dealers, designers, and installers. In this part of the country, we can call and get some technical assistance. In some other parts of the country, it's a little trickier to get that support. They don't have as many options. They don't have as many practitioners that they could call us. And we're really blessed here to have that. USDA, NRCS, equip cost share programs, and the groundwater conservation low interest loan programs made possible by funds from Texas Water Development Board that help make these technologies more accessible. Because those high installation costs, y'all know it makes these things a little bit more achievable and doable. And then finally, good collaboration among the researchers, the extension folks, the industry folks, and the producers. It's a good, perfect storm, I guess, if you will, of collaborations that make the whole package work. In deciding whether or not to adopt the technology, there's some things that happen, and one is that suitability and adaptability of technologies to this particular production system. We have low pressure center pivots, Lisa, or subsurface strip on cotton. It works. So we know that works. It's a good system. Economic feasibility. Will it work? Does it pay? Availability, again, I just said it. The accessibility of the industry and the technical support that we need to answer our questions and get things done in the field and make it work. And finally, the successful applications, and I appreciate Brad made this comment a while ago. You have the successful application of these irrigation technologies requires a good design, good installation, good management, good maintenance. So we have to be on top of the whole program. putting irrigation in context, I like to think that squirting water will fix everything, but I also have to lend credit to my colleagues in other disciplines. What we're looking for is crop yield and quality, and we want to have production efficiency, so we want to be efficient in our use of water, of our nitrogen, of all of our inputs. We want them to be efficient and efficacious, so we want these things applied at the right time, at the right rates, the right product, the right technologies to work well. And also looking at the optimal responses, looking at the laws of the limit. So if water is not my limiting factor, if I've got a disease issue that's just killing me, squirting more water on it may not fix it. Or it might be insects, or I might not have the right genetics. So I really do have to have all these tools together and look at the limiting factors. Nutrient management, variety selection, integrated pest management, got to put the plug in for the entomologists. Sorry, Greg. All right, and then of water management, and that's overall, it's not just irrigation. We learned that during this recent drought. We'd like to be able to control all the water, but the fact is we don't have enough water to supply all of the crops needs. We need to have the rainfall, so we need to take maximum advantage if we can build soil organic matter, look at that structure, and manage that to its fullest. Understanding the water holding capacity, very critical to managing irrigation. So that's where I'm going with this. A little bit of background and history, development of the low pressure center pivot systems, the LIPA and LISA systems that we're using, 70 to 80+%, depending on where you are in the high plain adoption rate of those technologies here. They work here. They were developed at Bushland. Bill Lyle, my predecessor, and Jim Berdowski, who still works at Halfway, were the developers of the LIPA system. And that is a system, right? You're applying water at the ground in alternate furrows. If I'm under a center pivot, I'm going in circles. The whole package that is the system. And then LISA, the low elevation spray application, a variation on the theme. And now we've got new things, Lubbock, MESA, and PARM. Greg Sikora informed me about PARM. That is precision application residue management, right? Please correct me, Greg, or whoever else could correct me. But I really appreciate it. And you guys are using these, so I don't really have to tell you what they are. The advancement of the subsurface drip irrigation application technology. And recently, maybe you read an article, there's a big award for a multi-state project group that got recognition from the USDA. This was truly a multi-state, multi-group achievement. And it is guys like Jim Berdowski, Freddie Lamb, Paul Kalezi, Larry Schwankel. Larry Schwankel, my recently retired counterpart from the University of California, great guy. Had this also, I'll show you in a few minutes about one of the packages that we developed with him, but really good guy. These systems are working. Another important development that was in the high plains at Bushland, the large weighing, monolithic weighing lysimeters. It's a big chunk of soil. Think of a big flower pot with essentially an undisturbed soil coil. This is no small achievement. They weigh a lot. Okay, they're really big. But what I'm doing is I've got them in the field. I actually weigh the water being added and used by the plant. There is no more accurate way to do it. Okay, there's also no more difficult and expensive way to do it. We have these things with Terry Howell. Terry Howell went and saw, back in the 70s, went out to California, saw how they did it there. He and Thomas Mark, as an engineer, designed and built these things at Bushland, installed them, and they're still being used today. Very important to get those crop coefficient curves we have to have for correct use of those ET base numbers that you're going to hear about in a minute. Subsequently, Thomas has designed and they've installed systems, similar weighing lysimeters, next generation lysimeters at the AgriLife Center at Uvalde, and Colorado State has put some in at Rocky Ford. So these are big systems, very important achievements. You're familiar with the ET network. I'm not going to spend time on this because you're going to hear more about it, but there's the Texas High Plains ET network, the Mesonet, the Texas ET network downstate. And these support a lot of applied irrigation research or a lot of your agricultural research. You need those data to be able to interpret what's going on in the field. Supports a lot of projects, supports regional and state water planning efforts, as well as irrigation decisions. So there's a lot of accomplishments there, a lot of contribution there through those ET networks. I also have to acknowledge that most of these developments and the subsequent projects I'm going to show you examples of in a minute involve interdisciplinary collaboration, the crop physiology, the entomology, the agronomy, all those other ologies. and other branches of engineering, the smart sensors and computer guys. Really important to work together, and it's really, it's challenging in a way because you're speaking 3 different languages in the room, and sometimes I get to be the interpreter between Jim Bernowski, who is a premier irrigation researcher anywhere, but he's developed his own language, and trying to talk to computer programmers who don't know anything about agriculture because we're developing this cool tool. And I'm the one, and I speak grower. And it's like living in an episode of Big Bang Theory, and it's really fun. But these fruitful relationships have grown with trust and with time. And you're in the trenches, you're in a room, arguing over terminology or arguing over which equation is the best one or whatever. But this is where the trust is built, and we accomplish these achievements. A few examples of some things that you've probably seen before, I hope you have, but I thought it might be fun to put them all in one place so you can see kind of some of the progress that's been made in this area. Comparison of subsurface drip uniformity designs in cotton production. Mike Buckstamper helped us design this system. We put in a drip irrigation system at Halfway, Texas with deliberately excellent and not so excellent emission uniformity. You remember putting in that study? What we were trying to do is how uniform does that system really have to be? Because if we could relax the standard just a little bit, we could get by with a lower installation cost. And we found that cotton in particular, and now this is a Pullman clay loam soil, remember that. Soil is important, the crop is important, but in that environment we could relax the standard a little bit without significant penalty in yield, because cotton is a very interesting crop and has an ability to compensate. If I'm short of water over here, it makes up for it over here, and it responds very well to the same amount of water, assuming you're not losing anything on the field. It's very important. Another study evaluating drip irrigation management strategies in cotton. This was work done with Eduardo Segura. You've got to have those ag economists to help you sort out, is it going to pay? But really looking at, is it better to concentrate on smaller acres, put our inputs more intensely, or spread it out over a larger area and take advantage of rainfall? Well, it kind of depends. What Eduardo and Jim found was that you could actually decrease that initial installation cost because drip irrigation is not cheap. Concentrate it on a small area. The water, if I have limited water, but concentrate the water and my nutrients and everything on smaller acres, it's going to pay. Unless I'm going to get good rain late in the season. You know, that July, August time frame, if I know we need to get better at this predicting weather, we really do need to work on that. There's your project to support him. If it's going to rain, that timely rainfall in July and August, spread out your acres. Another one, looking at a POCA. Some of you have noticed we have drip irrigation. Water quality is very important in drip irrigation. One of the problems that we encountered at Halfway, and we've also seen it west and southwest of Lubbock, manganese issues in the water. This black stuff plugging up the drip tape and the drip emitters. Jim devised a strategy for dealing with this, where you inject acid, lower the pH of the water, allow time and space for mixing, and then inject hydrogen peroxide to clean out those emitters or to keep those precipitates from forming in the first place. This is very important in helping us keep those systems viable. It's very, very expensive systems. Keep them working. We've got to maintain them. And these kinds of activities that Jim's doing really do help us to solve those problems. Another work looking at subsurface strip irrigation intervals. Do we irrigate multiple times a day? Do we irrigate every other day? Do we irrigate once a week? And what was found was irrigating on a 7-day interval was not worse than the yield and quality was at least as good as the more frequent intervals with cotton, and it was significantly better in 2011 and 2012 when we had those severely dry conditions. That's important. We're wetting that goes back to soil moisture. I'm wetting a bigger area of the soil. I've got a bigger root distribution, a more extensive root pattern that helps me take advantage of what rainfall I do get and also helps me mine those nutrients better. Spatial interpretation of daily evapotranspiration data. We can't have a weather station in every field. I guess we could. It costs a lot of money. But what if I have these stations? What if I could get better? Maybe the field, maybe the weather station 30 miles away from me, or I've got another one 20 miles away from me. Logic would say the 20-mile away one would be better, but maybe not. So spatial interpolation using kriging methods, Gaussian processing, and machine learning. I call it magic. I've got a smart young programmer working for me. Oh, good guy. I said, I don't think you can do it with machine learning. He did, and it looks good, but it's getting more accurate. We can get better representation, geospatial representation of the weather data at a location based on these. And with limited number of weather stations, this is very helpful. Smart people. I love working with smart people. This is great. Optimum irrigation levels for some of the new crop genetics in corn and cotton. This is important. We've got some, we're evolving over time. We've got some great new genetics. Now we have to keep chasing. How do we better? We want to manage these optimally to make the most of their potential. And some of the work that Winwei Xu and Thomas Mark with Steve Amison did up at Better and Halfway. Looking at if I've got a really good, efficient irrigation system, I'm basically managing everything well. 75% crop ET replacement is as good as 100%. I don't want to go below 75%. And then looking at the plant population. That's also important. And I know some of our seed companies are also looking at water levels, plant populations, and nutrient management. These are all very important in combination. So this work is ongoing. Another one, variable in-season irrigation capacity. This is kind of earth-changing for some of us. For years, we just filled the profile before the season and planted and hoped for the best and prayed for rain. Now we're looking at limited capacity or pumping limits, and we really have to pay attention to when we put the water on, how much water, where it's going and where it's going to be stored, where it's going to be taken up from. And some of the work that Jen's doing in the last few years has indicated that water applied pre-season and early season is largely wasted. It's better if I have limited water to save some of that water for later in the season when that crop is really going to use it and I'm really going to see a yield return. And the pounds of lint per volume of water applied is increased significantly later in the season. This is very important work that he's doing, and it is changing how we're doing our recommendations. And part of this is likely because we have new crop genetics, and we have to adapt our management strategies to accommodate these. North Plains up at Ed are looking at trying to grow corn with 200 bushel corn with 12 inches of water. And it can be done sometimes when it rains. You know, 2010 we did it, it was pretty good. 2011, 2012, not so much. And with Thomas Mark, if you know him, 12 inches is 12 inches. He didn't cheat and put 15 and call it 12. He really did it. The result was that with good irrigation management, you can do it if you have at least, so this is a better Pullman clay loam soil, very important. This is not a brownfield sand, okay? I can grow 200 bushel corn with 12 inches of water if I have 10.5 inches of water. Timely in-season rainfall. And he did a little statistical analysis and observed that would happen slightly less than 50% of the time. So sometimes you can do it and sometimes you can't. But that's good stuff. Now, how are we getting the word out? Trying to reach audiences, including our traditional audiences. Largely, most of you are growers or agribusiness, and so you've heard us a lot before. But we also have emerging audiences. And how are we getting the word out? What we want to do is get applicability or promote appropriate use of applicable technologies out there in the field. It's not a one-size-fits-all. Sometimes fish drip is a great tool for a lot of people, but it's not the answer for everyone. So we want to make sure, we want to try to promote appropriate application of the best tools in the right applications or for your conditions. The other thing is we want to try to, I've worked with a lot of researchers over the years, and part of what we can do is help improve the quality of research by helping, because we're not experts in everything, by working together we actually improve the quality of the research that we're doing. I'm working with an entomologist in Corpus Christi. on some soil moisture monitoring because he's looking at water management of some new genetics. And he really didn't know water management and irrigation management. So we're trying to improve the overall quality of that work and then provide the relevant educational resources to our audiences. We do this through demonstration and tours to show and tell things that we really enjoy doing. Those are fun. Conferences like these, like the High Plains Irrigation Conference we had last week. We've had several workshops at the Beltway Cotton Conferences and other venues. A lot of local meetings, going to the Southern Mesa Ag Conference tomorrow in La Mesa. So we get the word out, these, try to explain what we're doing, try to be available to answer questions. Publications, articles, fact sheets, newsletters, manuals, you've seen a lot of these. The focus on South Plains agriculture, try to get that weekly newsletter out and promote what's going on in the field, what are we learning, what are we seeing. Websites, including the Lubbock AgriLife, lubbock.tanu.edu, where we have a lot of research reports. The water management.tanu.edu, where we post a lot of our irrigation studies for the Lubbock and Amarillo Bushland Irrigation Group. What do we call ourselves? We need to make up a name for ourselves. The High Plains Irrigation Mafia, I don't know, something. And then one thing I wanted to promote, just kind of leave you with this, is I mentioned Larry Schwankel a while ago, University of California. He's also on that multi-state micro-irrigation team that was recently recognized. He has a book he published years ago about maintenance of micro-irrigation systems, and it's a really good book. But what he did before he retired, he invited Freddie Lamb from Kansas State Indian to come play, and what we did was adapt that book into a website, and it's a structured, kind of a decision tree structure. So I go in and say, am I having a problem with my drip system? Is it plugging, or if I'm just planning on putting one? Am I using groundwater or surface water? And this whole decision tree, I can troubleshoot. I get on this, y'all, I hate to give up my secrets, but you know, a grower calls me and I'm trying to figure out how to get on here. And I start asking him questions. And I'm sounding smart because I'm looking at the website. But it really is a lot of your clogging problems, and when you get down to the tree and you come down to the problem, it'll link you to a fact sheet on how to solve it. And it's really useful. So I really appreciate Larry and Freddie letting me play with them and put that tool together. Stop there. I'll be around. I'll be glad to answer questions, and I hope you have a great meeting. Hope you learn a lot here. Thank you.